Welcome back. In this video, I will explain you how to implement doubly linked list using XOR. This is a conventional single linked list where the addresses are directly written over here in the address part, that is the yellow region, so that each node can be linked with the other nodes like this. In a doubly linked list, we have the similar structure with an added address part. This 521 is the address of the next node and 743 is the address of the previous node, and we get a doubly linked list like this. The first node, of course, will have the previous pointer as null, and the last node we have the next pointer as null. So we have two pointers as previous and the next in each node. When we implement doubly linked list using XOR, we have a similar structure with the singly linked list like this, that we have a single address part, but there will be no address actually in these yellow regions, but something else. So we remove these addresses and consequently the arrows also get vanished. Now the question is, what will be there in these yellow regions? Let me have an enlarged diagram, because this yellow region will have something else which is not address. So since this is not having any address here, we are not having a direct link between these nodes. So I did not put the arrows here between these pairs of nodes. Now what we have in this yellow region? We have the previous node's address XORed with the next node's address, right? So we have the similar structure there in the other nodes. Now to move from one node to another, since there is no address here mentioned, but XORed value of the previous address and the next address, so you have to go for some computation each time we want to move from one node to the other. Now if we replace this prev and next with values, then we will have 0 in place of prev, because there is no node in front of this node, because this node is the first node now. So prev will be replaced with 0 and next is there at 478. So next is replaced with 478. We perform an XOR operation, that is bitwise XOR, and of course this 0 and 478 will be in binary form, and after XORing we will have some XORed value and that value will be stored here. The same thing goes over here also. Prev is replaced with 743 now, and next is replaced with 521. We XOR these two values in binary form and put the result here. We have this and we have this. Please note the last node here. There is no node after this last node. So next is null. So 0 has been placed here in place of next. Now let me explain what is the logic behind this XORing these two addresses and storing over here. So how will you move or how will you evaluate the next node's address when you stand in any of these nodes? So first you have to understand the advantage of XOR. For example, say the address of A is 0, 0, 1, 0, 1. Address of B 1, 0, 0, 1, 1. And you XOR this A and B. So if you perform bitwise XOR, then this 1, 1 will get you a 0 over here, because in XOR, if there are both 1s or both 0s, it yields 0. And if any of them is 1 and the other one is 0, in that case, it will produce 1. So here, it will produce 1. Here, it will produce 1. This one will be 0 and this one will be 1. Now we will go for an interesting thing here. We will put this XORed value as a second operand now, like this, and the address of B will be the result. Now you just check here that 0 and 1, if XORed, then it yields 1, 0, 0 yields 0, 1, 1 yields 0, 0, 1 yields 1, and 1, 0 yields 1. That means if you XOR this address of A and the XORed value, you get B. Now you verify this XORed value with B. These are the two ones and it will yield a 0 over here. These are the two zeros, it will yield 0. This is 1 and 0 yields 1. Both ones yield 0, and 0 and 1 over here will yield 1. So the interesting thing is that out of these three, you take any pair and XOR it you will get the third one. Right? So you XOR A and B, you get this XORed value. You XOR A and XOR, then you get B. And if you XOR this XORed value and B, you will get A, right? Now, if you stand here and you want to move to the next node, what will you do? You get the Prave's address. At this moment, the Prave's address is 0 here, and you take the XORed value here. You perform an XOR operation with the Prave's address and the XORed value, and you get the next address from here to here, because this XORed value has been computed using the Prave's address, that is 0, and the next address 478. So this XORed value is one component, the Prave's address is the second component, and the next address, that is 478, is a third component. Now when you perform this Prave address with the XORed value, then you will definitely get the 478 over here. So you see that every time you move from one node to another, you have to perform XOR operation between the previous address and the present XOR value, right? So here you see previous address is 743. You perform XOR operation with this XORed value and you get 521, right? So the same way you can move from this third node to the fourth node. So this is the logic behind using XOR in implementing doubly linked list. Now if you want to get back from this third node to the second node, what you should do? You get the next address, you perform an XOR operation between these two because you have got this XORed value, and you will get this 478 so that you can move from here to here. So this XORed value is actually helping you to move forward and backward. So this is the logic of using XOR in implementing doubly linked list. Now the question may arise in you that if I stand over here, then how will I know the next address? Because I have to XOR the previous address with the next address. So previous address is already there. I can get that previous address, that is 743, with the help of a temp pointer, which I can start from the starting node using the start pointer, right? But how will I get the next address? So that is a question, because to store this XOR value here, I need the next address. Now let me illustrate this to you. This is a start pointer pointing to the first node at 743, and this is vacant. There is no other node. So this portion is 0 because Prave's address is 0, next address is 0. So if you perform XOR operation, then you get a 0 over here, right? Now you have a new node which is created at 478, say, and it is pointed by mnew with the data 29 inside, and you have to link between this first node and this new node will be the second node. So what you have to do, you have to store the XORed value of the previous node and the next node. Now you know the previous address is 0. So 0 will be there, and you will get the address of the next node from mnew. So you use mnew over here, which will tell you the address of the next node. So you perform the XOR operation between 0 and the mnew's value, and you will get the XORed value over here. It's so easy. Now you may use the temp over here, what I have told you just now. You can start temp from start, writing temp equal to start, and you look over the addresses like this to find the last node of this list. So the temp will be standing on the last node. Now one more thing we have to do here, we have to fill this portion up. So it will be temp, that means the previous pointer here, and it will be XORed with 0 because there is no next node here. So it will look like this: 0 XOR 478 in binary form, and bitwise XOR operation will be performed. Here also 743 and 0 will be in binary form, and bitwise XOR operation will be performed. Let us add another node here. Say this one is created at 521 and we put data 89 here inside. Now this mnew is pointing to the newly created node at 521. So what you should do? You start temp with the first node and you move temp from this node to this node using the XOR operation, and you place temp on the last node. Now one more thing I should mention you that you always take a Prave pointer which will be following the temp because you will be needing it. So here is your mnew, the next node. Here is your temp, the current node, and prev will be the previous node. Now you update this XORed value here. This 743 will be XORed with the mnew's value. So you write like this, 743 XOR mnew. Now where from you will get this 743? You will get it from prev. So you need this prev here, which will be following temp. That means wherever temp goes, prev will be one node behind temp. And you update this one, that is the previous node is temp, and the next node is 0, that is null. So XOR it and store the XORed value over here. So in this way, you can create a doubly linked list by using XOR. In the next video, I will show you how to implement doubly linked list using XOR in C language. Thanks for watching and take care.